Hello and welcome, and in today's video I shall be speaking and demonstrating 7 different methods of edge finding on a milling machine. Now to start with, one of the most important things that you need to know, and quite often I suspect people disregard, is that the head of your milling machine must be fully trammed in to the bed in X and Y, so that you know, not only do you end up with you know, your holes and slots being perpendicular to the surface, but also if it's not trammed in properly, the edge finding will not be accurate. Now the reason I say that the edge finding may not be accurate is because generally edge finders are only 3 inches long and you know, pretty close to the spindle. So of course, you know, you've found your edge, and then of course if you then need to say either wind the head up or the table down, say 6 inches, to get a chuck and a drill or a reamer or whatever in, any error of the tramming will show up in inaccuracies of the hole positioning. I mean, as an instance, I mean, say your head was 1 minute out of perpendicular, which is a 60th of a degree. I mean, not very much. I mean, you wouldn't be able to see it by eye. I mean, that will make a difference of nearly 2 thou over the 6-inch movement, as I say. And most milling machines, you know, got a so-called scale engraved or even printed on, and there's no way that you know, by eye that you could get it you could get it right. So really, to get accurate hole positioning with edge finding, please ensure that your head is trammed in. So what we'll do now is I'll move you around to the milling machine behind me, and we'll get set up with the first method of edge finding. Join me over at the milling machine soon. Bye. Now, what I'm hoping to do with this video is to use what they're called chapters, so that you can, after watching it, you can immediately jump back to a particular section that you liked, or of course if you know of a lot of these methods, you can just skip to the ones that you're interested in. So I've never done it before, so I'm hoping it's going to work. The other thing I'm hoping to do is to use a second camera, because what I'm doing is a comparison between all these different methods and see what any errors are, and I'm hoping to use a second camera on the digital readout, and I'll actually then put it as a picture-in-picture. Hoping this all works. So without more ado, let me get started and set up on the first method, the pen and paper method. So what's this pen and paper method, I can hear you saying? Well, what it is a pin that can be, say, a dowel pin, a piece of high-speed steel tool, broken shank of an end mill, or even silver steel. It doesn't matter what it is, as long as it's straight, a known diameter, and got no burrs on the end. Now what I've got here is there's two that I use. I've got a piece of quarter high-speed steel tool steel for when I'm working in Imperial, or I've got a 6mm carbide shank up a broken end mill. So the procedure is to you can put it in either a collet or a drill chuck. I use my all-brick drill chuck here because it's accurate. So the idea is determine what you're going to do. But I should be working in Imperial, so I'm going to use this quarter piece of tool steel that goes into the chuck. Now the other thing is that you got to bear in mind is that, and by the way, this method, you don't have a machine running at all. It's got to be stationary. So the idea is that you first off bring the bring it down to this is the edge that I'm trying to find. What's happened here? Oh, I've got the depth stop on. Right, bring that down to there, and visually just bring this up close to it, just to determine whether it is here, whether it is running out or not. So just bring it over and just physically do it, and twiddle and turn it round. Now, don't worry if there is a little bit of run out. What you've got to do is to find out. Just saying this is only visually. Just look at the gap and rotate this to either the biggest gap or the smallest gap. The choice is yours. And when you found that, rotate this, the chuck, by 90 degrees. And in that case, or that instance, what that's done is that's now averaged out any run out that you're likely to encounter. Now the next point that you can need to do is find yourself a piece of paper to use it as a feeler gauge. You can actually use an ordinary steel feeler gauge if you want to, but so the choice is yours. So what I've found is that a piece of 80-gram printer paper is, for all intents and purposes, 4 thou. It's actually 4 thou and 2/10, but I mean, considering what we're actually going to be doing here, so the idea of it now is, as I say, no spindle running. You actually put this in between and slowly move back so I've got my microphone wire around there. Slowly move it back, moving the paper. That's too much. That's actually just pinched. Yeah. That's just got a nice. It's just holding itself there where we want it to be. Now, if this is going to be a manual setup, with no DRO, so what you would need to do then is to set your dial to 0. Lift the tool out of the way, and then you would need to wind your dial back half the diameter of the pin that you're using. In this case, this is a 1/4 pin, so I've got to wind it 125 plus 4 thou for the thickness of this piece of paper. But as I say, what we're actually going to do now is I'm going to switch up to the DRO and show you what I'm going to do with that. So just bear with me a moment while I switch the other camera on. I'm hoping this is all going to work. I'm hoping to film this as picture in picture, but bear with me if it apologise if it doesn't work. So here we are up at the DRO. So what you need to do first off is just to zero it out. We should be working in Y, so just ignore the top one. Now the other thing that we actually need to do is to leave this in absolute mode, ABS, which means absolute. I should be working in imperial, so, and that's showing imperial on there. If it wasn't, see, if it's like that, not displayed, that's metric. So we need to make sure we're working in imperial. So what we need to do now is to wind this back so that it reads 129. So where are we? Oh, 100, that's too many. There we are, 100 and... Come on, where are we? 129. Coming up. I think, right. Oh well, that's only 10 type. We'll go back and actually get that right. We can get that better than that. Seeing I'm demonstrating it. Come on. Come on. Oh, it's still there. Anyway, we'll call it out. So what we actually need to do now is to zero that out. Now this is going to remain in this. I'm treating this pin method as the go-to standard. So what I'm going to do is now each of the following methods that I'm going to show you will be within reference to this, to showing whether it's more accurate or less accurate. So all other moves now will be will be done in the incremental mode. But I think what we've done is now is we'll call this it. What we've done, as I say, just to prove the point, you see, if we just bring that down, there we are, the the pins on the centre line of the part. So I think we'll call that it for this one, and we will now go on to the next method, which will be the wiggler or wobbler method. See you in a moment. Bye. Now this next method is what is known as either a wiggler or a wobbler. It's a device that you stick in your collet, and it's got an arm with a ball on it on either end, and the principle is that when it as soon as the edge of the ball goes over the centre line of the part, it'll actually fly out. I've never used one before, and in fact I didn't own one. In fact I had to purchase this one just for this demonstration there. Now for this one you do actually need it running, so somewhere around about 1000 RPM. So we'll just start that up, and as you see, wobbling like mad. But I say what you do need to do now is to slowly bring the your part in contact with the ball, and so you've got to be quite gentle with it. So I say, starting to run through and through and through her, and then the instant it flies off, which is going to like to be any moment now, I suspect. Come on. There, and it's blown off there, and that is now the setting point. Now, if you were going to do without a DRO and manual setting, again, what you do is you take this out of the way, you zero your dial, move it back half the diameter of the ball, in which case this is 6mm. Reset your dial and away you go. But as I say, what we're doing here is we're comparing it to we're comparing all the different methods to see what accuracy there is between it. So bear with me a moment, and I will turn the other camera on, and we shall then go up to the DRO and talk you through it. Join me in a moment. Right, so here we are back at the DRO. Now what we need to do is now to switch to the incremental mode. I mean, what that actually means is a DRO's got two modes. You've got absolute and incremental. And what you've got in effect is two readouts in one, and you can change the settings on any of the range, on any of the two settings without it affecting the other. So because we've kept the pin and paper one is going to be our reference, we've got to make sure now that I switch this over to incremental. That's a metric ball on there, 6mm, so we actually got to switch that to metric. We zero that out. Now this ball isn't exactly 6mm, it's 6.01, so I've now actually got to wind this over to 3.005. I've gone too far. There we are. Now zero that out again. Switch it back to imperial, because the pin was imperial to start with. Shows it back imperial, and then switch it round back to absolute. And there we are, and that is showing minus 6 thou and a tenth. So what that actually means is that this reading is reckons that it's 6 thou and a tenth closer to the part than what the other one, what the pin and paper one was. So as I say, this is just going to be an exercise for showing you all the different methods. So and by the way, each method that I'm showing increases in cost, whereas the first one wouldn't cost you anything. You know, pin out your drawer, bit of paper, and that's it. Of course, you know, then of course you've got to buy this, and then the next one up is a standard wobbler and so on. So just bear in mind that each time it goes up, each different setting is costing more and more money. But so all I'm doing at the moment is I'm going to compare it. When I actually get to the end, I'll then show you a list as to say, you know, which was the most accurate. So I think what we'll do now is we'll adjourn this bit and now go to the standard spring edge finder. So join me in a moment when I've got that set up. Bye for now. So what you're now seeing here is a typical sprung edge finder. It's the tip is it's got a spring inside. The surfaces are lapped so that it, you know, it can slide about, and they come in all sorts of shapes and sizes. I mean, this is a 10mm one, and there's one here that is only I think this is 0.2. Yeah, this is an imperial one, 0.2 of an inch. So, you know, but different shapes and sizes. Now, again, this needs to be done with the spindle running. Again, about 1000 RPM. So what we'll do is we'll wind that over there. You drop this down. Same principle as the last one, but I suspect this is going to be much more accurate than the other El Cheapo one, because then this costs a lot more money. So again, as I say, run it about 1000 RPM. You slowly wind this back. When you get close to it, it will run truer and truer, and then what it will do is it won't fly out like the other one, but it will just kick sideways. So I'm just slowly advancing the table until it kicks out. Yeah, so it's kicked out, and it's now got a wobble on it. But you know, bit of a job for you to see end on, but sideways it's absolutely kicked sideways. So again, what we do now with that is move it out of the way. If you was manual, set your dial to 0, wind it back half the diameter. This is 10mm. Reset your dial to 0, and away you go. But as I say, we are now going to move over to the DRO again. So if you bear with me for a minute, I'll turn the other camera on again and see if we can capture the DRO method again. Join me in a moment. Right, so here we are at the DRO again. So as I say, what we've got to do now is to ensure that we're in incremental. We need to be in metric because that's a 10mm edge finder. Zero the Y out, and now I'll move this over until it reads 5mm. Where are we? Now 5mm. Zero that out again. Go back to absolute and in imperial. And again, that is showing a little bit more than the other one. That is now nearly 7 thou. That's 6 thou and 7/10. Right. Right. Okay. So that's that little a demonstration done on that. So what I'll do is now is I will switch over to method number 4, which is an electronic edge finder. Join me again after I've set it up. I'll see you soon. Bye. Right, so what we now have in view here is an electronic edge finder. It's just a shank that goes up into a collet. It's got a battery up inside. There's a little LED inside, and this is the other contact. What happens is when this touches your part, makes a circuit, and on comes the light. You see that light coming on, LED coming on. Right now, this manufacturer says don't do it with the spindle running, and other manufacturers say yes, do it with the spindle running. So I mean, I can't see why you mustn't have it running. I've done it in both methods, and to be honest, I find that with it actually running, I get a better reading by about a good hour. So the other thing you've got to bear in mind is that this is delicate on the end. It's not sprung loaded like the other one. So if you go crashing this into your part, you know, you're going to bend it, break it, whatever. So anyway, what I'll do is I'll show you in action. So what you've got to do is say, typical, just carefully wind it over until the light comes on, and I like to stand behind it so I can see a bit of light. Because I'm looking from the back, and the light should come on any moment now, I should think. Got to be very gentle with it. I mean, to be honest, I think it, yeah, and the lights come on. So according to that, you know, that's it. So again, you would raise that up out the way. You know, as per before, you know, manual, reset your dial and all the rest of it. So I said, but what I'm going to do now is I'll switch over to the DRO and see what the difference is. Back again in a moment. Right, so here we are. We're back up at the DRO again. So what you've got to do is to make sure we're in incremental. We need to be in imperial this time because this is a 0.2 thingy watts it on the end. Sorry, the brain's going here. So zero that out. So wind it over 0.1. Come on, here we are, nearly there. 0.1. Zero that out. Go back to absolute. And it's showing the error as nearly almost 7th hour. So, well, not error. This is showing the difference of 7th hour compared to the pen and paper. What we're trying to say at the end, there'll be a list, and you'll see how it all it ties up. I mean, so far the different methods so far are pretty close to each other, but not compared to the pen and paper. But anyway, we'll get back to that in due course. So that's the end of this little bit. So the next one that I'm going to set up, and that'll be take me a little while, is using what they call using a DTI and what they call a projected edge. So I shall be clocking up the edge with a DTI, but anyway, I'll explain it all. You know, it'll all come to like, oh, train, woo woo. Never mind. Right, over and out for now, and I'll say I'll join you again in a moment with the DTI one. Right, so what you're seeing in this setup, which is going to be called the projected edge method, uses a DTI, and the principle behind it is that you set this up so that the stylus at the bottom has got the minimum amount of you know, running as down here, running as true as you can. And then what you actually need to do then is to lower it down and then turn this around until you get the lowest. Well, you turn it around first off, and then you actually then bring the part over till you get a reading. Oh, it doesn't matter what it is, as long as you've got some reading on there, and then find the lowest point. Now you can't actually see that from there. I'll move the camera in a minute, but the idea is just showing you the principle. You've now found the lowest point on there, and you can set your dial on the top to 0. You then move the indicator up, and then what you actually need to do now is turn this around 180 degrees to find the other side, but of course there isn't another side, so that's where they call it the projected edge comes in. You get yourself a little little parallel or a high-speed steer, a ground block or a J block, and the idea is that you then put that lower this down a little bit more so that it's fairly near the top, and then you then carefully push that onto the keeping it firm against the edge, and then again adjust the indicator around to find the lowest point, and then if you then need to, it's like centering the hole, you then need to, if it's not exactly right, you've got to adjust it, you know, half the difference, and keep going backwards and forwards until it reads right. So what I'll actually do now is I'll go through the motions again, but with the camera on, so you can actually see what the actual indicator is doing. So bear with me a moment, and I'll move the camera and zoom in a bit so you can actually see what's happening with the dial indicator. Right, so here we are with a close up of the setup. It's down on the edge, and you swing this to and fro to find the lowest point, and it's about there. So we'd adjust that around to 0. You then move the indicator up, rotate it around 180 degrees. Be a little bit closer than that, and then using your Joe block or parallel or what it was, known flat surface, is you gently push that up against there, and then rotate the, of course you're having the job to see it now, but rotate this round until we find the lowest point again. Now this is indicating, you can't see it from there, but it's indicating +1. So what I'll do is I'll back this off by half a thou, and re-zero this. Move that, rotate this 180 degrees, bring it down onto the part again, and find the difference again. Oh well, I don't know what's gone wrong there. We'll have to reset that. Perhaps there might have been a bit of that. You've got to be quite clean with this. Yeah. So let's find that on there again. Sorry about that. So it must have been a bit of dirt or something under it. So you've got to be extremely careful when doing this. You've got to rotate this around 180. Just wipe this. I'll wipe that off. Move that down again so it's still above, and then carefully place it. As I say, so it's a real fiddly setup, but it's one of the accurate ways of finding it. Put it on there, and then tweak this round again to find the lowest point, and that is saying 6. So I've got to adjust that back to 3. Wrong way, adjust it round to 3. Bring that round again, lower it down, and find the lowest point again. Now this is number 6, the toolmaker's chair. Now this is a professional. Let's try and help I get it in shot, wouldn't it? This is a professional piece of equipment, oldie worldy, you know, back from the 19th, from the 20th century. Probably not greatly used today. Heck of a job to find. Took me nearly a year to find this one, and same was over £100 second hand. So what it actually is a precision ground and a lapped block this is a magnetic surface here, just here, and what it is this point here is exactly on the centre line of this. So what the idea is you pop it onto your, make sure it's clear, say it works on steel, it will work on non-magnetic, but you'll have to hold it, say, and it sits there like that. So it works on the same principle as what we've just seen on the other one, except of course that this time what we got to do is just to sweep the gap to get equal distance. So we just have to fiddle arse with the setup. Right, sorry about that. Yes, it's like dialing in a hole. You got to get your indicator in a rough position. So we've sort of got that so that it's about equal. So what we actually do then is just now drop it down into the slot and set it to 0, and then turn it around 180 degrees. See what she reads, and that is 7 thou. So we split the difference. Back to there. Round to this side again. That's still 4, so we split the difference again. Exactly the same as dialing up a hole. Yeah, so she's 0 at the back. Zero at the front, and because like the last one, as you see, it's much quicker than fiddling about with the projected edge. Because this is actually visual, I've now glanced up at the DRO, and it is 3 thou and 7 tenths. But I know you won't believe me, so I'll just move the camera up there and show you. Where are we? Oh. There we are. Absolute Imperial 2037. So that's that proved, so to speak. Well, that's that little bit done. And so I think what we're doing now is to set up for the final one, which is a Swiss-made optical centering microscope. So join me back soon, and we'll show you how all that works. Join me again soon. Bye. Now what you're seeing here in this final setup is a Swiss-made Isoma centering microscope. All it is a powerful microscope that's got a graticle in the bottom with crosshairs and circles, and all you do is you look down there and you line your edge up on the centre line of the crosshairs. Unfortunately, I can't show you anything because it's I can only just get my eye in there to see it. So you'll have to take my word for it. But as I say, all you do is just you get it in focus, and then just wind your table to and fro until you find the edge. Of course, obviously, if you want to do you can find a corner with it, you know, because you've got a centre point, you've got crosshairs on it. That's all I can say about it. Comes from the 1960s odd, arm and a leg to buy. Then I mean, I've had a look on eBay, and there's only two. I can only find 2 available in the world, and they're over $1,000 that they're asking for second hand. So the chances of you'd likely to find one is probably extremely slim. Anyway, I've set the thing up, and as I say, and it's reading minus 4 thou and 9 tenths. I suppose you'll want to see that again. I'll just grab the camera and show you. There we are, 4 thou and 9 tenths. So that's the that's the accuracy of that. So I think what we'll do now is we'll just put that back down to there, is we'll close this up now, and we'll go indoors and get the chart out, or make a list of whatever the errors are, and then you know, we'll close it up. So bye for now. I'll see you again indoors to close this out. See you later. Bye. So here we are again. In conclusion, I decided to since the camera was all set up out here, and bother to take it all in the house and set it all up in there. So here we are. So in conclusion, what have we learned? Well, there's the results. I don't know whether just to recall that, say the pen and paper was set up just as a known reference point, and then all the other measurements were taken from it. Now these are in thous. So it is although it says 662, that is 6.2 thou. And all the measurements are minus, which means that they're these items said that it was closer to the edge than what the pin was. So as I said, we've got the Wobbler 6.2 thou, the standard edge finder and electronic edge finder 6 thou and 7/10. The DTI, that was the projected surface, in case you remember what that's about. That one was the most second to most accurate. That is 4 thou and 9/10. The most accurate one is the toolmaker's chair. That was only 3 thou and 7/10. And lastly was the optical, which is 4 thou and 9/10. So as you see, just, you know, they're pretty close, and in fact, there's no doubt you found yourself using a wobbler or an edge finder. Sometimes they don't always kick off at the same point. You know, you've done it, it's kicked off, you've set your DRO, whatever it is, and you think, I'll just try it a second time, and you get a totally different reading. So you reset it again, and then try it perhaps for a third time and get a different reading again. So as I say, the edge finders are not particularly reliable. So I said your best bet is, if you really want accuracy, is a toolmaker's chair. But like I say, you might have a job to find one, and it'll cost you an arm and a leg as well. Now I forgot to mention in the video the first four. You know, the pin, the wobbler, and the edge finders were all mechanical. So obviously, you know, once they're kicked off, you then you know, set your DRO and then wound it over half the diameter of the whatever the diameter was. So of course, you've taken out, you've removed any backlash. Now of course the projected edge and DTI, of course, is yes, you've got it, you've found it visually, but of course you've no idea where your bleed screws are. You know, it could be, you know, one might be plus, one might be minus, whatever. So as I said, you really ought to back it off, take out the backlash, and then bring it back up to the same reading on the dial. On the DTI, and then reset the dial. I explained this in a previous video that says I forget what it's called. Was it getting to know your backlash or whatever, something like that? And of course, lastly the optical one. I mean, that is although it's optical on there, yeah, it's mechanical. So just make sure that you know that when you're lining up the crosshairs on the gradical, that, you know, you've taken your backlash out in whatever preference that takes your fancy. So well, I hope that's enlightened you a little bit as to you know, the different methods of finding an edge. The pin one is quite useful. I mean, if although you're showing this 6 thou, I mean, in general, I mean, if you're just working to standard sort of, you know, rough engineering standards, you know, plus or minus 10 thou, well, you know, pen and paper's ideal, you know. You can, or if it's just a case you say, well, okay, you know, I want it to be about 2 inches in, sort of thing. So instead of, you know, getting your ruler and a pencil, you know, if you want to, you can get it to you know, to within a reasonable specification. So I think we'll call it as that. Call it as day. So thanks again for watching. Please like, subscribe, ring the bell, send me a comment, and until we meet again with another video, and I've still got 2 or 3 more in mind to do in the not too distant future. Wherever you are in the world, please stay safe, well and happy, and catch you on the next one. Bye for now. Bye.